Welcome back to day 3 of our 62-day low-level design course. Today we will explore one of the most foundational and transformative concepts in object-oriented programming, the solid principles. Whether you are designing a small module or a large-scale application, these principles guide us in building software that is clean, adaptable, and future-proof. Our goal for this session is to demystify solid, illustrate how each principle works in practice, and equip you with the mindset to apply them in your everyday coding decisions. Have you ever worked on a code base where changing a single line of code breaks 10 unrelated things, or struggled to add a new feature without rewriting the half module? These problems are often the result of poor design. Solid principles introduced by Robert C. Martin, affectionately known as Uncle Bob, are the antidote. They help us write software that is easy to maintain, extend, and test. In other words, they reduce the cost of change, a key goal in software design. Today, we will see how Solid can turn messy code into a joy to work with. So, what exactly is Solid? It's an acronym for 5 design principles that, when followed, result in robust, modular, object oriented code. The 5 principles are single responsibility, open closed, list scope substitution, interface segregation, dependency inversion. Each principle addresses a specific pain point in software design, from managing class responsibilities to dealing with tight coupling. They may sound abstract at first, but by the end of today, you will see how practical and powerful they really are. Let's begin with the S in Solid, the single responsibility principle or SRP. The idea is simple. A class should do one thing and only one. That means it should have only one reason to change. For example, consider a user manager class that handles user authentication, data access, and login. If you change the way you authenticate users, you risk affecting logging. That's too many responsibilities under one roof. By separating concerns into auth service, user repository, and logger, we reduce risk and increase modularity. SRP makes your class focused, easier to test, and easier to reason about. Think of it like the difference between a Swiss Army knife and a precision tool, both useful but for very different purposes. Next, we move to the open closed principle. This one says that software entities that are classes, modules, functions should open for extension but closed for modification. That means we should be able to add new features without rewriting existing code. Imagine a payment processor class that supports credit card payments. Now we want to support UPI or PayPal. Instead of modifying the existing logic, which risks breaking it, we introduce a common iPayment method interface and implement new payment types as separate classes. This keeps the original code intact and promotes reusability. The open-closed principle shields stable code from frequent change, which is especially useful in large or legacy systems. The list scope substitution principle or LSP builds on inheritance. It says that any subclass should be substitutable for its base class without altering the correctness of the program. That sounds technical, but here's a relatable example. Let's say you have a bird class with a fly method and you create a penguin subclass. Penguins don't fly. If the program expects every bird to fly and you insert a penguin, things break. That's a violation of LSP. To fix it, you might rethink your hierarchy or separate flying behavior into its own interface. LSP helps us avoid misusing inheritance and encourages better abstraction. Now let's talk about interface segregation. This principle says don't make clients implement interfaces they don't use. It's about avoiding fat interfaces. Picture this. You have an iMachine interface with methods like print, scan, and fax. But what if you are building a basic printer that only prints? Should it be forced to implement all those methods? Absolutely not. The solution is to break the large interface into smaller ones: iPrinter, iScanner, and iFax. Each client now depends only on what it actually uses. Interface segregation promotes flexibility and reduces unnecessary dependencies, which makes our system more adaptable. Finally, we arrive at the dependency inversion principle, one of the most powerful and misunderstood principles. It states that high-level modules should not depend on low-level modules. Instead, both should depend on abstraction. Let me explain. If your application service depends directly on file logger, then any change to how logging works means changing the service too. But if Both depend on a iLogger interface. You can swap in file logger, console logger, or even a database logger without touching your code logic. This principle encourages you to code to interfaces, not implementations. It also opens the door to dependency injection, a technique we will cover later, which leads to highly decoupled testable code. Let's see the difference Solid makes. On the left, we have a before scenario, a monolithic class doing everything from business logic to persistence to formatting. It's hard to test, hard to maintain, and prone to errors. On the right side, we see the same system refactored with solid principles. Responsibilities are clearly separated, classes are loosely coupled, and changes in one area don't repel through the rest of the system. It's more scalable, readable, and elegant. This is what Solid enables. Let's take a short quiz to reinforce what we have learned. You will see multiple choice questions and code snippets. Your job is to identify which solid principle is being violated or applied correctly. Feel free to discuss your reasoning with a partner or in small groups. The goal here is not just to memorize definitions, but to train your design instinct to start spotting design flaws the way experienced developers do. Let's reflect for a moment. Which solid principle felt most natural to you? Which one challenged your current coding habits? Can you think of a time you accidentally broke one of these principles, maybe by stuffing too much into a class or tightly coupling your service to a database? These are great points for discussion. By sharing your thoughts and hearing others' perspectives, you deepen your understanding and start to internalize these principles. Your assignment is to review and refactor a sample food delivery module that violates multiple solid principles. You will analyze the design, identify the violations, and rework the classes to align with what we have learned today. Be thoughtful. Think about abstraction, dependency management, and responsibility separation. Submit your work by day 5 and of day. We will do a peer review on day 6 to compare solutions and discuss different design approaches. If you want to explore more, I recommend Agile Software Development by Robert C. Martin. It's a foundational read for design principles. Also check out refactoring.guru, an amazing resource with visual guides and interactive examples. I have shared a downloadable cheat sheet and optional video lectures to help reinforce today's material. Design mastery doesn't come from a single day. It comes from repeated exposure and practice. To sum up, SOLID is more than just an acronym, it's a mindset. These 5 principles give us the tool to write code that lasts, evolves, and scales. As we move forward in this course and in our career, that these principles guide our design thinking. Don't just write code that works well and works long. Practice, refactor, and refine. That's the essence of great software design. Thank you for your attention.